These incredibly powerful AIs, they're kind of like brilliant geniuses who've read the entire internet. They know a ton about, well, everything. But sometimes you just need them to do one very specific job. And today, we're going to break down exactly how you teach a genius to do just that.
So let's start with the question. Can a super smart AI, one that deeply understands language, actually spot a simple spam message? I mean, you'd think so, right? It seems obvious, but let's put it to the test.
So we took a powerful language model and we gave it a really straightforward instruction. We just asked a simple yes or no question about this message, which is, classic spam.
And what did it do? Well, it just repeated our own question right back at us. It got totally confused. It couldn't follow that simple direction. And this, right here, this is our starting point. We have a genius that could probably write a beautiful poem, but it can't do this one simple task yet.
All right, so how do we fix this? The secret is a process called fine-tuning. We're about to take our brilliant generalist and transform it into a focused, highly skilled specialist. Now, when it comes to fine-tuning, you've basically got two paths. On the left, there's instruction fine-tuning. That's how you get a versatile assistant, like the chatbots we're all used to. But for our problem, we need what's on the right, classification fine-tuning. This is all about teaching the model one single job and making it an absolute expert at it. In our case, an expert spam spotter.
And every great student needs a great textbook. So the very first thing we have to do is create the perfect study guide for our AI.
Our source material is this dataset right here. It's a big collection of 5,572 real-world text messages, and each one is already labeled as either ham, which is just a fun way of saying not spam, or spam. This is the raw knowledge we're going to build on. But we've got a problem. The dataset is way out of balance. We have so many more ham messages than spam messages. If we tried to teach our AI with this, it would just learn to cheat. It would figure out that it can just guess ham every single time and still get a pretty good score. And that's not what we want. So to fix that, we create a balanced textbook. We give our AI the exact same number of examples for both sides, 747 ham messages and 747 spam messages. Now it has a fair chance to actually learn what makes each one different. And just like you would in school, we split this data into 3 piles. 70% is the main study material for training. 10% is set aside for practice quizzes. We call that validation data, so we can check its progress. And that last 20%, that's the final exam, a test it will never see until the very end. Okay, so the textbook is ready. Now for the really wild part. We need to perform what you could think of as a small brain surgery on the model itself. This is where the magic really happens. See, a normal GPT model is designed to predict the next word from a huge vocabulary, like over 50,000 possibilities. We don't need any of that. So, as you can see here, we basically snip off that original output part and replace it with a tiny new one that has only 2 possible answers, spam or not spam. It's so important to get this. We're not retraining the whole brain. We're just changing how it gives us its final answer. So, how does it decide which one to pick? Well, the model reads the text piece by piece, or token by token. And because of this cool thing called causal attention, by the time it gets to the very last token, that final piece has absorbed the meaning of the entire sentence that came before it. That makes its final thought the most informed part, and that's the perfect place for us to get our final verdict. All right, our student is prepped, and the surgery is complete. It is time to start training. Let's watch as it goes from just making wild guesses to becoming an expert. So, before any training at all, we give it that final exam. And its score? 48.75%. That's basically a coin flip. It's just guessing. This proves that, right out of the box, our specialized model has absolutely no idea what it's doing. And now, the training montage. Over 5 rounds of training, we call them epochs, you can see exactly what happens. On the left, its mistakes, what we call loss, they just plummet. And on the right, its correct answers, or accuracy, they shoot straight up. This is our AI literally getting smarter right before our eyes. So after all that studying, what's the final grade on the test? A stunning 95.67%. We did it. We successfully turned our confused generalist into a super accurate specialist. The training worked. But, okay, a good grade is one thing. Does it actually work in the real world? Let's go back to our original problem and put our new expert spam spotter to the test. Remember this message? The exact one that completely stumped the original super powerful model?
We feed it to our new specialized model, and boom, it nails it. The verdict? Spam. Clean, simple, and most importantly, correct. This is exactly what we wanted to see.
But what about a totally normal message? We also have to make sure it doesn't just call everything spam. So we give it this simple text.
And the model's conclusion? Not spam. Perfect. It has learned to tell the difference with incredible precision. Our fine-tuning process was a total success.
So we've seen how you can take a massive general-purpose AI and teach it a very specific and highly accurate skill. And this all leads to a really fascinating question. Now that we know how to create these AI specialists, what job should we teach one to do next?